Alright, let's work on our first medium problem. Today we're going to be working on, it changed a little bit of my pace. Probably going to be working on two medium problems, or at least try to, uh, in a day. I'm currently set up for 22 weeks, 16 hours per week, so 2 hours a day. So our first medium problem is going to be insert interval, LeetCode problem number 57. You're given an array of non-overlapping intervals where, so it's an array of int arrays where intervals I represent the start and the end of the ith interval. Intervals are sorted in ascending order by start. You're also given a new interval that represents the start and end of another another interval. Let me take a look at what they actually want, because I'm not entirely sure. Let's see. Return intervals after the insertion. Okay. Insert new interval into intervals such that interval is still sorted by ascending order by start. Okay. And intervals does not have any overlapping intervals. Merge overlapping intervals if necessary. Interesting. Okay. 1, 2, 3, 5. So these are non-overlapping intervals that we're getting. They're basically pairs, I guess we could call them, right? They're just pairs of start and end. And then we have a new interval that we want to insert in. It looks like we want to preserve okay, so we want to cover the entire interval, but we don't want to. So the goal is essentially to insert the new interval such that the resulting intervals covers the entire space without overlap. Also, merge as many intervals as possible. Okay. Let's see. So they're sorted in ascending order by their start, not their end. But we know that at the beginning for sure that none of the intervals overlap. But when we insert, that's when they start overlapping. Okay. So what can we do with that information? This is an interesting problem because I'm not too sure exactly where to start now. Let's see. We could reasonably find where it belongs by the start, right? We know the start and the end of each interval, right? So we can reasonably say, like, if it's between here and here, so this would be a, let's see. You could say for each interval in intervals, check first to see if the array can let's see. Let's see. Check first to see if the array can fit. Is that the word that I want to use? Check to see if the array can fit within any interval. And in that case, it would be, let's see. We would check the first, the beginning of the check first the 0th index, right? Check first the 0th index to see if interval 0 it should be less than or equal to new interval 0, right? And if interval, if interval 1 is greater than or equal to new interval 0, we just return intervals. That's basically, in that case, we have complete overlap. If it fits within the left and the right side, then we're fine. We don't need to worry too much about that. This should be new interval 1. If interval 1 is less than new interval 1, then we need to start checking the other intervals. Right, so 1 and 2, so 1 doesn't work, we move on. 3 works because 3 is less than or equal to 4. However, 5 is greater than, or 5 is less than 8, so we check the next one. And at that point, what are we looking for mainly? What are we looking for in those? I think mainly a upper bound, right? So the idea is that, okay, we have a 3 here. We know that for each, so we have a fact that each interval beyond our initial lower bound will have a start less than, or sorry, greater than start of our current lower bound, right? So 3 and then whatever start will be afterwards. And then what we want to do is that if that interval is greater than the lower bound, or sorry, greater than the upper bound. So if that int next 0 is greater than new interval 1. So basically, if this value is greater than the initial value, or than the upper value, then that means that we don't have an extension beyond our current interval. Therefore, increase the bounds and return. Right? If this is less than this, otherwise, check to see if, let's see. So we check this lower bound. It works, right? Because it's less than or equal to 4. Then we know 5 is here. Let's see. We know 5 is less than 8. So then we move on to the next section. 6 is less than 8. So we continue. 7 is less than 8. Continue. 8 is equal to 8. So in that case, if int next 0 is equal to new interval 1, then the bounds become, within this interval, it becomes interval 0, which is our original one, and int next 1, which is the upper bound of our previous, or of the interval that reaches. Basically, it just overlaps. That actually seems reasonable. The point, I guess, is now how do we sort of describe the removal? So how do we remove unnecessary intervals in that case? Well, we could try. I wonder. We could start off by just copying the values whenever necessary and ignoring everything else. So this would be if we go over an interval, pass, or add to the array. Once we insert our new intervals, then add the rest in. So this would be O of n space. As for time, that's a good question. Because what I imagine is that, the idea is that once we hit a point where we could potentially insert our interval. Actually, no, it would start here, right? Because 1 is less than 4. 2 is less than 8. So we continue. 3 is less than 4. Or, yeah, 3 is less than 8. Five is less than 8. Why is the interval not 1 through 10? And then 12 through 16. Because that interval is completely under. Okay. So we want to make sure that our criteria to start searching is that the left is less than, or we want to make sure that the right side is not less than the beginning here. And then when we search, we find something like this. Then we start searching the rest. So what would be the runtime on that? We're not doing this evaluation for every single array in the list. We're just starting with the first one for now. So this is kind of like a greedy solution, in my opinion, in the sense that it finds the first possible candidate and it sort of just slides in with it. I'm not entirely sure what the time complexity of this problem or of this solution would be. It feels almost linear because we're not really doing the trick where we're searching here, then searching here and the rest, and then here and the rest. That would be a polynomial time if we did like search 4 of these subarrays, 3 of these subarrays, 2 of these subarrays, and then last subarray. We're just doing it once. So I'm tempted to say linear runtime. I might change my mind on that, but I think this is a fine first solution. This O of n space is a little bit weird, but going off of what I had yesterday, it might be a red herring that it could be improved in a reasonable amount of time. We'll take a look at this. We can revisit it towards the end, but for now I think I would like to start coding this. So in this case, because we want to skip around a little bit, we're going to need to do some things. So we're going to first start by creating a list because we don't know how big our final array will be. And that might be the way that they actually force us to put this into linear or into constant space if we have to use intervals, if we have to mess around with intervals, but I'm not too sure. We can get back to that later. We can call this interval list is mutable list of int array. That starts off empty. We can declare a variable which will be our index that starts at 0. I wonder if I can manipulate index in here. We'll actually see if we can. Intervals dot size -1 to go through the all the intervals in the interval. And actually, we can do var index is 0, and then while index is less than intervals dot size -1, or less than intervals dot size because we want to go to the last one. We can say index ++ at the end in case, just so we don't do anything stupid like forget to do that. List, is there just a generic toArray function? Maybe there is. Hopefully there is. And we can say if, let's say, intervals at index dot 0 is less than or equal to new interval dot 0 and intervals index 1 is greater than new interval 0. Basically, we want this right side to be greater than the start, first of all. Right? Because then it can fit in that interval. So we're checking here if this is greater than this, just to make sure that it can fit. So 5 is less than 4, so we can start with this interval. When intervals at index at 0 is greater than or equal to new interval 0, and intervals index 1 is greater than or equal to new interval 1, return intervals. So this is just a little bit of optimization, I guess. So if the beginning is we can say it needs to be less than or equal, right, in order to fit inside. And if the interval at the right edge is greater than or equal to, then we just return it because it fits neatly inside without any interference. However, when intervals index 0 is less than or equal to new interval 0. Actually, I think all of these are all gonna have this case. I might move it up to this if case then later. Intervals index 1 is less than new interval 1. So that would be this case right here where the 5 is less than the 8. What we want to do is to hold on to this reference, left index or left interval index, left interval index is -1, or sorry, is equal to index, our current index. If left interval index is -1, because we don't want to override it, that we currently have. So 3 and 5. So the left side is less than or equal to 4. However, the 5 is less than the 8. So what we do is that we record this index, so 1, and then we move on. So in that case, we move on to 6 and 7. 6 is greater than index 0 is greater than new interval 0. So if it's greater than here, and intervals index 1 if it starts greater than this edge and it ends, what did we say? If the interval's next 0 is greater than the left edge, right? Interval list add. You want to add an int array. Int array of. We could do intervals or left interval index. Left interval index is not -1. And we want intervals 0 and then new interval 1. So if the right edge here is greater than the edge here, so for example like this, right? So 1 and 3. So 1 is less than or equal to 2, and 3 is less than 5. Then we override our left interval to be 0. Now, going to the next step, our interval on the left side is actually greater than our right edge. And our previous left interval index is not 1. So we add an int array that takes the left side of here and our right edge here. We add it, and then we go on our way. We might need a flag here that basically says add or do not add. Because in this case, don't add current index, or don't add current interval. Add current interval because it does not overlap. But in this case, it 5 is or 6 is less than 8, so we move on. Intervals index 1 is greater than new interval 1, and left interval index is not -1. So this is the other case where if this right edge actually goes through, then don't add current interval, need to merge. Interval list dot add int array of intervals, so left interval index at 0 and intervals at index of 1, because this is greater than or equal to. So if our right edge is greater than or equal to, so say this was an 8, then we would want our new interval to be added as 3 through 8, or 3, 8, right? But we also have another case that our intervals index at 0 could be equal. In this case, we also want to, so new interval 1 So either the intervals, and I want to, okay, sorry. Yeah, so because we know that at this point it should be greater than, left to right, the start interval should be either greater than or equal to, if it's less than, then it doesn't matter. But in this case, if it's greater and it's not 1, we add it. If it's equal to, such as in this case, we also want to do the same thing where we add it, where we add the left edge of here and the right edge of here. Similar thing if this was an 8, right? Yeah. And actually, it's greater than or equal to. The interval's there. Then we add the right edge there. Greater than or equal. Yeah. Okay, that makes sense. Okay. And then let's add a variable and let's say has found, or actually we can just say else if left interval index is equal to negative, or is not equal to -1, then we want to add it. Intervals. Basically, I want to just finish. I basically want to finish, and then like just grab the rest of the intervals that don't matter here. I'm not sure this is the best way to do it, but in both of these cases, we want to set the interval index to -1 because we've already added our interval index, and we've added our interval index and we're done. So we just yeah, we just want to add the rest of the intervals in. Because the in-between ones we want to merge, so we don't want to add them to the list. So let's add some print lines just to see where we're at right now. This isn't something that I'd probably do in an interview. It's just not a very clean solution to just add print lines and do print line debugging. I want to see, just in case we do screw something up. Let's just do that. And this shouldn't trigger at any of the points beyond it because of the sorting. Actually, it might. That's a good question. We could just do that. And we don't mess with that. If left interval index. We could just add it in that case then. We want to get rid of one of these, right? Yeah, cool. Okay. Setting left to intervals, or left. Yeah. Right to new interval 1. Setting left to intervals. I could just copy and paste the same thing. Right to this. Gotta love me some good old print line debugging. I'm not even sure if it needs the debugging, but we'll see. Probably, because I do not write very good code. Adding interval of left intervals index 0, intervals index 1. See if it compiles first. 2 arrays. I see. Kotlin documentation to the rescue. Array. They have typed to typed arrays. That's an interesting question. There's no like direct to array. That's a good question then. I guess the question really becomes, how many do we... Is there a way to calculate how many we need beforehand? I don't think there is. But... let's see. Array... Is it just that? Yeah, it's just that part that's causing issues. Problem is that we can't really turn... we can't turn a list into a generic array. Is there... I want an array documentation, if possible. I just want to check this array of... I know that there is there. I know that there was like a. Let me look at the collections documentation again. Come on, Kotlin. I'm blaming the language for this search. Just want collections. I know that there's like the zip operator. Does this turn into var args? No. Hmm. Okay. Val return array is equal to array of type int array sure. And I need to specify the size, right? That will be interval list dot size, and then interval list for each index. I'll call it IDX because I don't want to confuse it with the other index above. Value return array at IDX is equal to value. A little bit more expensive on the space side. I'll see if I can get that fixed, but first I want to see if this actually even works in the first place. No value. Private structure. Array. Which means I can do an array of size interval list where this index is interval list at I. Does that work? Let's see. Oh, this should be size. Okay, cool. Let's take a look. Setting the left interval index to that. Oh, whoops. That was a bug in my debugging. Let's see. Setting the left interval index to 0. Okay. Setting left to 1, right to 5. Okay. And then we don't add that. Let's see. Why not? It's not less, the interval at 6 is not less than those. It's greater. It's greater than the right edge. Yes. Maybe we don't want to do this, but that might cause some weird issue. We know that left interval index at that point wouldn't be 1. We hit this setting left right to 5, and that would be new interval 1. This would be this one, because the left edge in this case is greater than. And in that case, we are also free to add our intervals. Yeah, index, because it's overshadowing. I put this comment here to add the current interval because it doesn't overlap, and then I completely forgot to add that. Wonderful. Let's run our second test case. I imagine that will have some issues, yeah. Let's see. Let's do a var has inserted false. Actually, we can just do the left interval index is -1. Set to -1 to avoid adding additional copies in the future. One, 5, 6, 9. Ooh, interesting. Interesting. 1 to 2 is just completely ignored. Let me take a closer look at that. What is the result of that? Setting left interval index. To index 1. Yeah, I kind of forgot about that part. So if it's just less in general, if the right edge is less than that, then we just add it. Okay, let's see. Adding interval of left 6, 7. We do not want to add this. Left interval index is not -1 because we're using that as the flag now, I guess. Actually, no, we want to add it if it is. Whoops, did the opposite. Basically, if we haven't, if we either haven't hit the point yet where we're starting to merge, or if we are after the point where we're merging, then we want to add those intervals. add the rest of the intervals that don't matter. Just run through the other code. Just to make sure that I haven't missed anything. Okay. Cool, cool. Let's see. Are there any edge cases to consider? Let's see. I've considered where it completely overlaps. I've considered the case where it doesn't overlap with the next interval. Where it overlaps with the next interval at the beginning. And where it overlaps with the next interval at the end. What if it doesn't overlap with any of the intervals? That's an interesting question. I want to try that. I feel like we're going to have an edge case there. Because this won't go through. Yep, I see. Let's see. How should we handle that then? If it goes over the edge. You gotta add another when case. That's fine. If the intervals index 1. Well, first of all, if index is equal to intervals size minus 1, and the right edge is less than our current new interval 1, then we just want to do we don't need to do the left interval index thing because we're at the end, right? So we can just do an interval list dot add int array of intervals left interval index 0 intervals index 1. And we actually also need to consider the case where it just we also need to consider the case where it doesn't overlap, and also the case where the interval is completely outside. Oh, not the index. I want the new interval. Right, so let's also do that. Let's also consider those cases. So we'll check 4 to 5. So actually I'm gonna do this, and then we can do 1, 3, 6, 9, and 4 to 5. Let's just copy and paste those other test cases. Just want to speed up the testing process. That's another edge case if it just completely doesn't overlap any of them, right? So in that case, 1 to 3. Well, 1 is less. 1 is less than 4. 3 is less than 5. And the left interval index is there. That's a good question. We can set the left interval there, but ultimately it should sit here between. And how do we know that it sits there in between? We know that this is 1, this is 6, but it could be anywhere between 1 and 6. If it sits right in the middle, I think the simple solution would just be just adding another case, but we're starting to pile up on cases. That's not quite great. If left interval index is not -1, so we have a left interval, and intervals at left interval index. Well, we know by the fact that we have a left interval index that it's greater than, it's greater than the left side and the right side. So we know that it's greater than the right side. So if it's less than the left side of some new interval, do we have that? Yeah. We have greater than. Oh yeah, it's here. We know that this interval, this 1 is less than the 4. Oh, but the 3 is also less than the 5. So when we would skip this first case, right? If intervals is 1 is not greater, so it just adds 1 to 3. It adds 1 to 3. It's less than here. What we could do is that we could do if left interval index is not, or is -1, then intervals. Ooh, would this interfere with some of the other ones though? Because we're running with the intervals list as -1 as a flag, so we might need to change it up a little bit. So interval list dot add. We just add our new interval. Else, you can just do that. Not you. Because we want to add the new interval regardless, because it's exclusive. Oh, and then we want to remove this clause. Come on, LeetCode. Okay, so it seems to work for there. Let's run the rest of them because I have a sinking feeling that we probably ran into some regressions here. What did we regress? We regressed the second case. Where we added 4, 8. Let's see. Okay. So, to solve that, not the best solution, but has inserted false. We'll use this value actually, yeah, well, if we haven't, no, if we have, yeah. This is to add the rest. This is to add the rest. I don't think that I missed any of the other cases. Maybe I have. Let's see. Am I still running into that? I see. Okay. Wait, is this a different issue? 3 to 8. So we're adding 1 to 2, 3 to 10, which is correct. But then we're also adding 3 to 8, which would be left index and new interval 1, which would be this case, and not has inserted. I wonder if there's a similar case for this. Oh. Oh dear. Now we're adding that. Why are we adding that? We are adding to index. And the interval index 1. So 16 is not less than 8. I don't know why we're inserting that. Gonna put that in here. I'm assuming that we're adding that one. Because that's the only, because here would be has inserted. Yeah, okay, so it's adding there. Or at least I assume so. We can take out some of these other tests. Gonna pop it into a random VS Code box that I don't care about. Just to make sure that it's actually adding for this one. Otherwise, I was just going a little bit crazy. Okay. So it's not adding there. It's not adding there. Then where is it adding? Not adding intervals index. Oh, it is. Yeah, it is adding intervals index. It's 12. 12 is not equal to 4, or 12 is not equal to 8, rather. Not has inserted. Cool. So now that should be correct. Yes. Let's test that. There's a lot of cases here. A lot of cases to consider. I'm not even sure if I've tackled them all. Let's see. So I've tackled that and that. What if we run into the opposite situation? So we did 2 through 10. What if I did like a 1, 3, 6, 9, and then the value we want to insert it was like 10, 12. So let's actually run this back here. Would that be caught by this case? No, it wouldn't. Let's see. Intervals 1 is less than here. Because intervals 1... Let's see. This is the right side, so is 9 greater than 10? I see. How do we... I guess we could just do if not has inserted. If not has inserted, then interval list add new interval. The problem is that I feel like this case, okay, so that works for there, but like what if we did something like, let's have 2 to 3, and we'll have 0 to 1. And imagine this will be out of order. Oh no, interesting. Let's see. Why does that work? When intervals index 1 is greater than that, when your code works and you don't know why. Okay, so the right side is greater than, yes, 3 is greater than 0. Let's see. It's not less than or equal to, it's greater than here, and we haven't inserted. Okay, so 2 is less than 1, and we haven't inserted it. So, and the left interval index is -1, so we add it. We add the 2, 3, and then we has inserted true. And then the next cycle, we has inserted, so we skip to here, and then we interval add 6 and 9. Cool. Are there any other cases that I'm missing? So it's under, and then inside. Let's actually do it inside one. So let's do like a 2, 5, and we'll do like a 3, 4, right? Just to make sure that this top one works. Awesome, awesome. Okay. Let's see. So we have an inside, we have a before, we have an overlapping inclusive with the left interval index. We have overlapping multiple. We have over the limit, right? We did test over the limit, right? Yes. And then we have a over the limit on the right side, which would be let's see, remember we did one, yeah, 210. This one, the right side goes over, and then we have one that just goes over entirely, which we have this case for. So there's like, honestly, there's not too many cases, but it seems like we have regressed on one of them. We've regressed on the 210 case? Which one was that? Oh, I see. I see. That's 1, 3. Regressed on the 210 case. Okay, interesting. So we got 110 and 210. Interesting. Right, because we didn't do has. We need to set the flag whenever we insert something. Okay, so now when we run the full suite of tests of cases that I thought of, this should be correct because we've added it. Okay, cool. Let's see. We don't need to set it here because this is just setting the left current interval. This is insertion either before everything or within. This is insertion of in between with the merge, with the left value index and then the right, because this value is greater, so it encompasses the other part. So like in a case like this where we want to do 10 because 10 is greater than or equal to the new interval, it overlaps with that. This is the case where we go over, so if we're at the edge and the intervals still is like that, technically you could probably actually merge this with this one. Hmm. Hmm. Do we want to consider a case where this isn't actually true? So where this overlaps, this one actually overlaps the interval one. Let's see if we can think of a case where that could happen. 2, 5. Would it be possible for the right-hand side to overlap in there? If we did, let's do 10, 12 here. Let's do 2 to 5, and we'll do 3 to 7. And let's see. This would get caught if this is greater than this. Then by default, because the original array is sorted, or because the array is non-overlapping, then it is not possible, I don't think, for our interval to be greater than here, than our left side array, or really just any arrays, the right interval, without bumping into another. Without bumping into either this case, where our interval on the right side is greater than our upper bound, or in a case like if we do 612 here, right, where our interval is less, or rather, where our interval on the right side, our 12, would be greater than this. So either of those must be true. So I think this actually covers the case where we do overlap or we do overshoot in the middle. So the main concern is just overshooting at the end, or completely overshooting and not having any completely overshooting and not having any left-hand side and just not inserting at all. So I think this is actually a pretty good test suite for most of the cases that at least I can think of off the top of my head. So I'm gonna go ahead and run it and see if there's any test cases that we missed, as well also in terms of just like whether or not we were fast. 1527, that returns 27. Or that returns, we return 27, it returns 17. I see. Was there a left interval index here? Let's see, 1 is greater than... If intervals 1. So that would be 5. Is 5 greater than 2? 5 is greater than 2, so we do enter this block. 5 is greater than 2, so we enter this block. 1 is less than 2. And 5 is less than 7. And left interval indexes that. Okay. So basically, I guess in this case then we check if left interval index is equal to -1. Otherwise, interval list add int array of intervals left interval index at 0. Or new interval 1. I think that works. And then just run it against our test suite. Let's run it against this input as well, just to make sure we haven't regressed on anything. And we'll run it through again. Run it through again to see if there's any other test cases that we missed. Interesting. 1557. I thought I had that. No, I had it in there. I had it there. Intervals 0 or index 1. Oh no, that's an interesting case. Does that not insert it into there? Let me think. 5 to 7. 5 is not greater than 7. Or 5, no, 5 is greater than or equal to. Is that it? These are a lot of test cases though that I missed. A lot of test cases that I missed. I'm not even sure if this runs efficiently. We'll see. Lots of trial and error programming though. Man. 1 to 5. So 1 is greater than or equal to 5. One is greater than or equal to 5. Starting to feel like this solution is a little bit unwieldy. It's starting to go beyond sort of the scope of like of what I feel like a medium problem is. So it's there's probably a much more elegant solution to this that handles all the cases that I'm just not thinking of. If an easy solution takes about 12 lines, a dozen lines or so, then I'm guessing a medium solution probably takes about a dozen or 24 lines. And we're going to the point where, let's see, line 22 to line 70, that's like 50. It's like 50 lines of code. That's a lot of code. Hold on. Okay. So 5, let's see. 5 is greater than or equal to 0. So it does go inside this block. Okay. Intervals index 0 is, no, 1 is not less than 0. 1 is greater than 0. 1, however, is not greater than 3. One is not greater than 3. Let's see. Also, should this be less than or equal to? Let's see. To new interval. Yeah, definitely should be. Let's see. Intervals index 0 less than new interval. So 1 is less than 3. And intervals index 1 is greater than or equal to new interval 1. Yeah, I can do that then, can I? And that'll add it from 1, or that'll add it from... Ooh, that'll add it from 1 to, that'll add it to 1 to 5. Not what we want. Let's see. New interval. So if it's both of these conditions, that here is less than here, then interval list add new interval 0. Or is greater than. And intervals index 1 has inserted true. Probably need to rewrite the solution. It's starting to get a little bit crazy. Probably introduced a bunch of stuff that I don't need. Intervals. Oh. Int array of. Let's take a second peek. So we just regressed on that one. Why did we regress on that one? 3 to 10. 3 to 10. It's one of the first test cases too. Should just be. Oh, I see. Because this is right there. Intervals index 8 is equal to 8 is equal to 8. Then why didn't this cover it? Intervals index 1. Ah, okay. I think I might have been right about that case. So if left interval index is equal to -1, else, and we can add this here. Interval list add int array of intervals oh no, this would be new interval 0, and then this would be intervals index 1, and we can get rid of this clause. Yeah, so my what I said earlier about like, oh, maybe this has a similar situation, like I guess that might have been correct, at least to a certain extent. Let's see. Again is mainly this. I don't, huh. So we're adding the left interval index left interval index 0 to no, it has inserted. So I'm pretty sure we did merge. Not an issue with there. It's pretty sure it's an issue here with has inserted 3 to 8. Adding 3 to 8 and 8 to 10. Why am I adding 3 to 8? If 3 to 8, let's see. We have our left interval index in that case. And then we're adding our intervals there. And why are we doing this double time? Because the question really is, why are we inserting it double time? Oh, this 8 to 10 shouldn't belong there. I feel like this 8 to 10 is probably being inserted prematurely. Like pretty sure about that. I'm pretty sure this 8 to 10 is being inserted at the end. Print line added. Again, this is definitely not the type of thing that you want to be doing in a coding interview. Yeah, it's being added at the end. Why is it being added to the end? Let's see. We add 3 to 8. If the left edge is equal to that, val upper bound is equal to new interval 1, or if new interval is greater than the intervals index 1, then new interval 1, else intervals index 1. Just insert the greatest one every time. Oh. Did I delete one for here too? Yep. Still not quite. Let's see. certainly here. Oh, this is the one that's being added. Upper bound. Is this not where it's being added? Is it this one? Let's see. Greater than or equal to. Yeah. This should just be purely greater than, I think. Because if it does, if it is greater than or equal to, then it overlaps. Alright, let's run the whole test suite now. Okay, let's run another submit. This is really messy. If this even passes, I really need to. Oop. 15 and 06. Let's see. If we're at the end, okay. Val lower bound is equal to if left or intervals. Well, first, if left interval index is not equal to -1 and intervals at left interval index 0 is less than new interval 0, then it would be intervals left interval index 0, else new interval 0. Lower bound. Make sure that we didn't regress on anything. Cool. 1506. And this is already checking to make sure that this is less than this. Cool. This test suite just keeps getting bigger. Eventually I'll just have all of them. Okay, so not the most optimal solution. It's mediocre in terms of speed and memory usage. It's fine though, it looks like, maybe. Maybe just a little bit slower based on the submissions. Maybe just some inefficiencies based on like how I implemented this. Overall though, this one was a little bit more rough. Just all those test cases, all those edge cases really screwed me over. I'm gonna have to go through this. I'm gonna take a look at the solution probably and just see like sort of how they organized all the solutions. Or maybe I'll just do some more additional work off camera just to see. But yeah, other than that, it's decent. I think the runtime is fast enough, judging at the percentiles, and the speed is, or the space is also relatively okay. Not super thrilled about this, but I mean, there's no way, like you have to return a new array. Because otherwise, well, you can't resize an array. That's just how arrays do be. I am interested in seeing whether or not there's a more efficient way to organize that, though. But in any case, that's it for LeetCode number 57, insert interval, our first medium. Not looking at the solution, but having to sort of brute force it towards the end. Let's see. But yeah, in any case, I hope you learned something, and I'll see you for the next problem.